Okay, so in this first video in the plotting module, I'm going to talk about the grammar of graphics. So formally, the grammar of graphics is a tool that basically enables us to speak concisely about the different elements in a graph. So what we're going to do in this video is that we'll use this as a stepping stone for talking about the different components in a plot and building up a plot from the bottom. Okay, but before we get started, I just want to load some stuff. So I'm loading NumPy and Pandas as always, and then I'm also loading our two plotting libraries. So Matplotlib, our main plotting library, and then I'm also loading or importing Seaborn here. So as we've already seen, Seaborn is nice because it's got these different data sets that we can use, but it's also got some quite useful plotting features, as we'll see in this video and the next videos. And then I'm also using this magic here. So I don't want to go too much into depth with what's going on here, but it basically just allows printing in the notebook. And then finally, I'm going to import warnings, which basically just allows us to ignore certain annoying warnings. Okay, but let's get started. So where to start when making a plot? So what we'll do now is that we'll begin with the fundamental and flexible way, as I said before. So we basically just start from our plotting canvas. Okay, so I do want to emphasize here that Matplotlib has basically got two interfaces. So it's got a state-based interface and it's got an object-based interface. And what we are going to use here is the object-based interface. So what we'll do here is that we'll define a fig object and an ax object. Okay, and that's here we're basically initializing our figure. So this is really just our plotting canvas. And here we're specifying the size of the plot, and we're basically implicitly specifying that we also just want one plot here. Okay, so this fig axis and this fig object and this ax object, what are these? So fig and ax, they're interrelated, but they're not the same, and it's important to emphasize. So you can think of fig as the actual plot which is displayed. So you can really think of it as our canvas. And this is, for instance, what we'll refer to when we're going to export a plot, but it's also if we at a later point want to display a plot that we have already generated, then we'll refer to this fig object. Ax, however, it contains most of the chart content as object. So it contains grid axis, it contains labels, and it contains all the shapes that we draw, etc. And maybe it's not clear now how these are different, but hopefully it becomes clearer in the rest of this video and the next videos. Okay, so is there a way to change the fundamental style of the plot? Actually, there is. So you can set the plotting style yourself, and you can select from all these different sort of default plotting styles. So usually we'll not set this explicitly, but it's actually possible. So in order to display the different plotting styles, you just write plt to access the Matplotlib, and then write style.available, and then you can see all these different styles here. So what we will generally recommend is that you use either ggplot or simply just the default style. So these are the ones that you'll most commonly see being used. Okay, so are there any other defaults that can be changed? Yes, there are a lot. And you can access these default configurations with this RC method here. And when we access these configurations with this method, we can basically change all sorts of default plotting styles. So for instance, consider the following here. So first, I'm just specifying that I want to use the default plotting styles. That was related to what we just saw on the previous slide. But then, for instance, I want to change the default figure size when we are creating a plot. So that's what I'm doing here. And you can see here, I'm using this RC method here. I can also change the fonts. So I basically do that in two steps here. So firstly, I'm creating a dictionary with keys here. So that's family, weight, and size. And then I'm specifying that I want the monospace, font, family. Then I want to write everything in bold, and then I want a font size 12. And then again, I use this RC method and specify font, and then I basically apply these keywords that I specified in this dictionary. Okay, so let's see how this works. Okay, so now our canvas has changed clearly. So again, we're simply just writing fig, comma x, and then PLT subplots. So we're fundamentally doing the same as before. We're just not specifying a figure size, but it has clearly changed. So compared to before, we had this. So comparing compared to that plot that we just saw, we have clearly changed the font family. We have everything is clearly written in bold, and also the size of these numbers has changed, and also the size of the plot that was specified here is also different now. Okay, so that's just now our default configuration. We changed that with the RC method. Okay, so now let's plot something on our canvas. So as I mentioned before, and as we've used before in this course, Seaborn comes with some quite illustrative data sets. So for now, we'll load the tips data set and just explore it a bit. So that's what we're doing here. We're loading tips, and then we just want to get an idea of how many rows we have. We have 244 rows. That means we have 244 observations, and then we're just printing the first 5 observations just to get an idea of the structure of our data. What can we plot here, and what are the different data types in these different columns in our data frame. Okay, so that's what we have here. Okay, so let's now plot the numeric variable total bill. And first here I'm specifying a TB to be an object that basically just contains this total bill variable. And then I write fig.x PLT subplots. Then I sort of specified these. I've created these 2 objects, fig and x. And then I specify using this x object that I want to create a histogram, and I want to create a histogram on this total bill variable. Okay, and then I get the following here. So here we have the distribution of our total bill variable in a histogram. So that's fairly easy to do, right? It requires very few lines of code to create this histogram, and given that we already changed the default configurations in our plot, we don't have to write too much code now. Okay, but now let's then make some graph specific customizations to this plot. So for instance, I mean, this plot is not complete, right? So for instance, we may want to choose a title for our plot. So we're creating this dictionary that basically holds these specifications. So we want to set a title. So that's what I specify here, distribution of bill size, then want an X label and a Y label. And then we also want to set the limit on our X axis. Okay, so then we use this dictionary with this set method of function, and then I just again plot this total bill variable. And we can now see that when we're using this dictionary, we can change all these different specifications on this plot at once. So we have changed the title, we have changed the X label, we have changed the Y label, and then we can also see that now the X axis goes from 0 to 60 instead of from 0 to 50. So that's quite convenient. So opposite to these default configurations, these specifications, they will not be used next time we make a new plot with Matplotlib. So it's just important to emphasize that what we did here was basically just temporary, while what we did with the RC method, it was fundamentally permanent until we change it again.